Good evening. Welcome to IoT North. I'm Paul Wheels, founder of IoT North. Welcome to our new friends from IoT Scotland. Great to have you on board. Thanks for registering and joining the show. We're now at 8,500 members across the whole of the UK. IoT North is not just about the North. We're about the whole of the UK. Anybody and everybody who wants to share their insight, tell us what they're doing with IoT, do a demo, which is what John's going to do, who I'm going to pull in line in a second. Get in touch, info@iotnorth.uk. We'd love to have you. We're building up the content for next year, and John and I were just having a chat about do we do the roundtable again for December. So if you'd be interested in doing a bit of a roundtable and just having a chat about the year and having a bit of reflection, again, email info@iotnorth.uk. And on what else we're going to tell you? So the marketplace, if you're interested in putting your solution on the website, it's free. We market it free across our social profiles. There is no charge. It is free. We'd love to have your use cases on there so we can share and evangelize about what you're doing with IoT on there. There is also the forum, forum.iotnorth.uk. If you go on there, you can register, put content on, reach out to other people there. Let's build this out. We've got 8,500 members, so let's move on there and let's start to talk regularly as well. Without further ado, here is John. Mr. Staveley, how are you doing, mate?
Yeah, really good, actually. I've been doing some Azure IoT Edge work for a customer at the moment. It's sort of the manufacturing line of the future. More than that, I can't tell you because there's an NDA, which is a bit dull, but it's a really interesting project.
Awesome. Yeah, I've been drowning in creating NDAs over the past month for myself as well. So can't talk about what that is about either. Yeah. But come Q1, I can start to share with everybody what I've been doing with AI Vision, which is a very, very cool product. Let's have a look and say hello to everybody. So we've had Ian Smith on there. Hi, Ian. Bruno, Dave. Hi, Dave. How are you? I think, yeah, Dave's one of the guys that I presented in Edinburgh. You spoke about some boards and I spoke about my... Oh, yeah, Dave, I remember you. So Dave did an absolutely brilliant talk. Dave, you need to come on the show and share this. He has an absolutely brilliant setup for his brewery, which was absolutely fantastic talk. Please do email info@iotnorth.uk. Let's show everybody on that one. It's John, you would love that one.
Beer in electronics. Life can't get any better.
Oh, I know, exactly. In fact, free samples, please. Coleman Clark from Edinburgh. Hi, it's great to see the Scottish crowd definitely joining us this evening. Hi there, Ibrahim, and Peter as well. Brilliant. Hey, John, do you want to tell us what you're going to be talking about, and let's get it kicked off?
Right, I will share my screen and get going.
By the way, if you want to say hello, just use the comments on the live stream that you're on, be it LinkedIn, Twitter, or YouTube. It'll pop up on our little screen here, and we'll say hello. If you have any questions for John, the harder the better, then please do throw them in the comments, and I will pop them up on the screen to make sure that John does answer them. That's not to make it hard for you.
Can you see presentation?
Yep, we can. There it is, mate. I'm going to step back, and I'm going to let you run the show, mate.
Yeah, thanks, Paul. I'm a bit of a techie, so yeah, I tend to get given all the really difficult problems. My name is John Staveley. I'm Microsoft MVP, most valuable professional, and tonight's talk's about IoT on Raspberry Pi. Raspberry Pi is a great platform. Some people say it's suitable for production, some people say not. I find it's quite a useful tool. My day job is I'm an IT contractor in C#, MVC, SQL, Angular, and Azure. So I do some work on IoT in Azure, and I organize Lead Sharp, which is a .NET developer community, and IoT North. I've used various microcontrollers before, and I know bits and pieces about electronics, but I am not an electronics expert by any sense. So hopefully I'll be giving you some pointers this evening about making some of the electronics a little simpler and a little easier to understand without having to get into the nitty-gritty of it. So what we're going to cover tonight, this talk was originally for C# developers, but most of it applies to any kind of development that you can do on a Raspberry Pi, or indeed with Azure. So that includes Python and C. I'm going to talk you how to set up .NET 5, control all the different things. So you've got general purpose I/O, pulse width modulation, and integrated circuits. They're the three main interfaces used to control things. So I'll be going through some basics about the kind of things you can control with a Pi. Don't worry if that seems a bit basic to you. We're going to be going on some more interesting cloud technology and how you interact with that later on in terms of the Azure IoT Hub. So we're going to push commands to the device to make it do stuff, but we're also going to be receiving updates from the device, both in real time, and I'll be demonstrating a website that links to the device directly wherever it is in the world, so you can tell it to do stuff or receive telemetry from it. So what is a Raspberry Pi? So it's got a variety of different interfaces. This is a Raspberry Pi 4B. This is the fourth iteration. It's not a platform that's going to go away. In fact, the British Foundation that was responsible for it has just been given $45 million to expand it and improve it. It's got onboard Wi-Fi. It's got a camera port. This is a camera port here. This has got sound, USB 2, USB 3, network card, 2 micro HDMI ports, USB-C slot, display port. And the stuff we're going to be talking a lot about tonight is the input-output pins. What you can't see hidden away under there is an SD memory card, and that contains the operating system, the Raspbian operating system that is installed. So a flavor of Linux, basically. Now, if you're interested in C#, this isn't the only device you can do C# on. There's another board called Meadow you can do the .NET Micro framework on, and also the .NET Nano framework on ESP32. I don't know anything about either of those other than they exist, so don't ask me any questions on those. So getting started, you need a USB-C power supply with at least 3 amps. Don't use your phone charger for this one because it's not going to be powerful enough to run everything. So there's various shops online that will supply you one that's 3.1 amps, and that gives you a good enough oomph to drive screens and network cards and the like. Then you need the Noob software, which you can download on the internet and pipe onto a micro SD card. And you need a screen compatible with micro HDMI, a keyboard, and a mouse. You just need those really at the outset. Once you've got the Wi-Fi set up, you can just VNC onto the device, and all of that can just stay detached. But initially, you need those to get things configured a little bit. I find a fixed IP address helps because then you can FTP files onto it and VNC onto a fixed address rather than having to find out what it is each time. So if you want to run .NET 5, Pete Codes has written a bash script. Unfortunately, it isn't apt to get install .NET 5. There is a series of steps you need to go through, and his blog details how you do all of that. I'm going to include all of the slides on the meetup site. I'm going to send out all the slides and the links and the code and everything. So yeah, you don't need to make notes on everything as I'm going along. You might want to install VS Code as a development environment. It's Visual Studio Code. That's free. I tend not to do that. I've got Visual Studio running on my laptop, and then I build, publish to a directory, and then SFTP over onto the Pi and run things from there. Once you've got code on the device, one of the things you need to be aware of is some of the security settings. Otherwise, things won't run. So when you boot up around the Raspbian operating system for the first time, it looks like that. And if you enable it to do something, you need to open the menu, go down here and select Raspberry Pi configuration. So we're going to be using these interfaces, and they're all off to begin with. So you need to turn on SSH so you can VNC, so you can connect to it, and SPI if you're using it. I use I2C and the serial ports. And how do we control things? So you've got digital input and output. So that's sending ones and zeros out of the headers. Pulse width modulation and integrated circuit connection, and the camera interface. So I'm going to be going through all of those interfaces step by step and the kind of devices you can run with them. So if you're using C#, It's all open source, and the two main namespaces going to be using is GPIO and binding. So GPIO is basically switching things on and off, and the bindings as anything more complicated, like an I2C driver or SPI driver or something like that. And it's all available on GitHub. So this is what it's about, and we're going to be talking about tonight. So broadly speaking, you've got these 40 odd pins, and they're divided into different categories. So I can get 5 volts output of the device, 3.3 volts output, the general purpose IO. So these are pins that can be configured to be either on or off. A load of grounds. I have no idea why you've got so many grounds to work with, but you have. Sometimes useful. So the hello world of embedded programming is switching an LED on and off. So here we're running a line from the GPIO pin. You've got a rate limiting resistor there connecting to an LED, and then going back on this common negative here to the ground. And the code looks like that. So you set up a GPIO controller. You say, this pin 18, I'm going to define you as an output, and then go through a loop and saying, this is high and this is low. So it runs like that, which is great. So other examples of digital output. Yeah, you can switch LEDs on and off. You can send buzzer sounds. You can send signals using infrared LEDs, similar to your remote control on your television. This is a low power laser and an LED, a relay unit. So the power you can get out of the pin is really very limited, very low current, and you don't want to burn the pin out, otherwise you can wreck your Pi quite a lot. Now, something about electronics. So if, like me, you don't know a lot about electronics, you can go to this website here. So let's say you've got a motion sensor like this. It's got 3 pins on it, but beyond that, you don't really know what to do with it. So this website is quite useful, and it gives you recipes in terms of how you can wire things up. So it's got 5 volt output and the ground and the GPIO to say whether something's moving in front of it. This is how you configure motors. So it's a really useful website. All the examples are in Python, but the wiring, knowing about the wiring is quite useful. And my goodness, you start hearing things like, oh, you need a pull-up resistor, you need a pull-down resistor, oh, you need an anti-short resistor or an anti-back EMF diode, and suddenly it gets slightly bewildering. So, for instance, here on this relay board, you can wire in an LED, a resistor, a back EMF diode, just to get a relay working so you can control higher voltages. But why not get a kit where you've got all of the bits already with all of the peripheral components you need? So all you're presented with in terms of what you need to wire up to the Pi is a signal, an input, and an output. So the Geek Creek unit is quite useful in this regard. So you've got a joystick, you've got a motion sensor, a distance sensor. This can tell, it can provide an analog signal. This is a moisture sensor. And then this book here shows you how to wire it all up. So this takes all of the pain out of doing the electronics for you. If you're like me and you don't want to spend a lot of time wiring resistors in, is quite useful. And it costs about £15 from Banggood. And I found it to be quite helpful. I'm going to talk a little about Azure IoT Hub. So we're going to wire in the IoT board to the IoT Hub, which is free for less than 8,000 messages per day. You can control 100 different devices. It's got an enterprise level message bus behind it in terms of event hubs. It supports a number of different protocols. It's got a couple of concepts like device twins and IoT Edge. So device twins is basically you send it a JSON packet and it says, I want a device that's configured like this. And then with each state change, you can just define an event handler in your code that says, has my twin changed in the cloud? If it has, then I respond to that and I can change my configuration. So the LED can be configured to be on or off when the device boots up, for instance. It's got IoT Edge, which is kind of like a Docker container type environment where you can deploy localized blob storage, artificial intelligence, image recognition, your own code. So like .NET code can compile and run on a Docker image. And then you can deploy it to Edge and have multiple modules running on that. So, I mean, I'm not going to go through setting up an IoT Hub because it's really very trivial. What you do is you create an IoT Hub Azure portal. It's basically just give it a name. Then you create a device in the portal, which is basically gives a device a name, and then set up a direct method. And you get something like this. So with Azure, you get this IoT Explorer. It's a handy utility. So here is my my IoT Hub. I've got some connection strings I can view here. I've got one device here called Raspberry Pi. And then I can send it a message called, so I've called my direct method control action. And then I've got this JSON blob here. So there's, just make sure it's running. That's always helpful. Okay, so I've got code. Oh, there you go, and it works. So that device is actually sitting next to me. It could be anywhere in the world. When you set up an IoT Hub and the device boots up, it opens up a persistent TCP/IP connection to the cloud. So with the IoT Explorer here, I've sent a message, and you've seen. So this the IoT Hub's running in a data center in Cardiff. So it goes to Cardiff, and then sends the message back to the Pi, which is listening to it, and says, you know, you got to do some stuff. So we just do that again quickly. So that's incredibly fast considering the round trip, and you know you'd expect it to be anywhere in the world. And the code's really quite trivial. So again, you know, the examples here I'm doing in C#, but they don't have to be in C#. They can be in whatever language you're familiar with. I set up a device client, and I get use a connection string. So that's the thing that was showing in the IoT Explorer. Then I define a method handler. So whenever a message comes in for that message handler, my method is executed. This is my method here. And it says, well, unpack the data as JSON and then perform whatever actions you want it. And I can provide all of the complete code at the end of the presentation. So let's talk a bit about the development experience. So I develop in Visual Studio. Some people use Visual Studio Code on the device. The key thing with Visual Studio is you need to set up to publish in the correct way. Otherwise, the Linux device will go, what's that binary? I don't recognize that at all. And the key things are, it needs to be self-contained, Linux, ARM, and .NET 5. Otherwise, it won't understand the binaries. Again, fixed IP address helps, not from a security perspective, but from just a development perspective. You can SFTP the files across using FileZilla and then execute on the device. Then you need a bit of Linux voodoo to say, well, this user can execute the files, and then /, my DLL is called control, and then that will run the DLL. Any questions so far? I've not been looking at any questions. Nope. Okay. Good stuff. So now we're moving on to digital input. There's a number of useful inputs you can get out of the device. So I'll be showing later on a push switch, which just works as you'd imagine. If you've got an alarm system at home and you've got two contacts on a window, one of them will contain a reed switch. So in there is two plates of metal, and on the other contact there is a magnet. And when the magnet moves next to the reed switch, it makes a connection. It induces a magnetic field and closes the circuit. So it's basically another kind of switch that can switch on and off. This is a magnetic sensor. Then we've got three types of motion sensor: a tilt, an up or down switch, and a vibration sensor. So you can pick up all different kinds of interactions with your device. This is a light blocking, so you've got an LED on one side and an LED receiver on the other side. So if something passes between, it opens or closes the circuit. And then the opposite of the infrared LED we saw before, it's the receiver for it. And this is a motion sensor. So again, if you've got an alarm system with a PIR in it, it will have one of these in, and it sends a signal when someone's moving in front of it and detects heat. Good stuff. Right, onto pulse width modulation. So this is basically sending a signal to a device that's external to the Pi, and the device will interpret what's called the duty cycle that it receives, and then do different things based on whether it's 0% duty cycle, 100% duty cycle, or somewhere in between. So here are two examples. So I've got in the top box, I've got a servo, and as you can see, the duty cycle increases, the arm sweeps across or backwards, and then the LED it comes on or partially on and then off. Now the cycle is so fast you won't be able to see it, but basically it's spending more of its time on than off, so the LED appears brighter. Now it's got some native PWM ports on the Raspberry Pi, two in fact. A couple of examples of PWM. You can run servos, which robot arms and legs, and then you've also got continuous servos, which I'll be demonstrating. Lamps fully on or fully off, motors, pumps, fans. This display dial, obviously, if the pulse is fully on, it's at the top end, and if it's fully off, it's at the bottom. And this is a YouTube video of someone playing the Star Wars theme tune using PWM, which is quite entertaining. It's easy to wire up, so you need power, you need a ground, and then you just need to send it a signal. Right, I'm going to stop talking and do a demo. Right, these are my PWM servos at the top. Now I've got a pan and tilt here with two servos running. So it's the kind of thing you could use for a directional camera in a home security system. These are what are called continuous servos. So the width of the pulse determines how fast it's moving continuously and in what direction. Okay, thank you. Oh, that's good. Right, and here is the ARM sweeping variety. So the pulse width controls at what position the arm is. So that's good for like robotic arms, and as you've seen, this pan and tilt device. So the code is quite simple. You've got software PWM, which, to be honest, I found a little flaky. Basically, the software is simulating sending pulses down. So if the operating system gets busy doing something else, then it's not quite as effective or smooth. But that's available in your code. What I prefer is hardware PWM. So you create a PWM channel and start it and then send it different duty cycles. So you define a pin that you're on, a frequency, and the initial duty, which is 50% in this case. And you get something like that. All that. So now we go on to I2C, or inter-integrated circuit. And this is where anyone who's got a hammer, everything starts looking like a nail, in that once you discover you've got this interface, you start solving all of the problems using I2C, because there's really a lot of peripherals you can control, and some really complex peripherals. So this is really quite appealing. It's a two-wire communication, so you've got a data line and a clock line, but generally you're wiring up 4 wires to everything, because you need a plus and a minus as well. And it's pins 3, 5, 27, and 28 on the Pi. It's short range, so you're not going to control something 100 meters away on it. The wires will suffer from capacitance and muck up the signals that are being sent down. As we've seen in the Raspberry Pi security configuration, you need to enable this, otherwise you'll get an error when you try and run code. And there's some useful I2C tools that you can install using apt-get on the Pi, and this shows you which devices are detected. This is really quite useful when you're plugging something in for the first time. It'll show you if it's wired up correctly, otherwise it won't appear as a taken port when you run that command. So some examples of I2C. You've got a relay controller, which I'll be demonstrating in a minute. A PWM controller, if you want to control more than the 2 devices you get natively with the board. Digital I/O expansion, if you've got a device where you've got maybe 40 ones or zeros on or offs that you need to send out to different devices. There's an LCD screen. I've got one of those wired up on the Pi at the moment. The Raspberry Pi doesn't do analog natively. So analog is anything between 0 and 1. The inputs it does understand is either 0 or 1. So analog is like 0.5. So it's good for temperature or pressure or humidity or that kind of thing. This is a GPS sensor. So that's really, you can see the pins on there is really easy to wire up. This is an RFID tag. So it can, you can understand what information is stored in that tag. Rotary encoder, which is like a volume switch, accelerometer, or external memory. Okay, so just to show you what this can do. So at the bottom here, I've got a solenoid. A solenoid is a big hunk of metal with thousands of wires, electric wires wound around it. So if you run a powerful enough current through it, it becomes an electromagnet and it drives the pin across. There you go. So this is all driven by this relay hat that's sitting on top. If I was doing this face-to-face, you'd see me go to my mobile phone. I would be tapping away on my mobile phone, and then you'd see the bar go across, and you'd be thinking, what is he doing there? But I'll reveal that later. Okay, so I've switched that off. Paul says we have questions, and I can't hear you, Paul. Does C# offer any particular advantages, say, over Python? I don't know, because I don't develop in Python. I just develop in C#. There's a huge amount of software, a huge community behind C#. It's open source. I'd say that's the best thing about it from my book. Python's got better machine learning. Oh, I can hear you now, Paul.
Ah, good.
Machine learning applications. Yeah. I wouldn't say I'm qualified to comment on that, but it does everything I need it to.
Can it be secured against physical hacking when deployed in the field?
A Raspberry Pi or your code?
This was when you were talking through the Raspberry Pi, so I'm going to presume that.
Okay, so the IoT Hub is, you've got a secure connection string, so that's pretty unhackable, as long as they can't get access to your connection string. A Raspberry Pi is not a secure industrial device. I strongly suspect it is hackable in some way. If you attach a device to it, you will gain access to the Raspberry Pi. It's, there's nothing there to stop you, I don't think, but I could be wrong. It requires more in-depth knowledge of the operating system than perhaps I have.
Yeah, Mike just qualified that his question was regarding both software and...
So you can encrypt the software so it can't be decompiled, or it makes it very difficult to decompile. So it would be secure from that perspective, and you could protect your IP that way.
Okay, excellent. They're the questions that we've got so far, John. If anybody else has any other questions, please do pop them in the comments and we'll answer them. When I say we, I mean John.
Cool. Right. So you've got your Pi working, and then suddenly you want to start connecting things to it. So you get into lots of prototyping. The first thing you need is jumper cables, so male to female and female to female. You can see them stretched across my demo board there. There's some male cables, and then all the components start getting really messy. So you have to mount them on something to stop them flopping about all over the place. So if you've got a breaker board in the front of your house with the fuses to the house in, they're often mounted on DIN rails. So a DIN rail is this metal bar on there, and a lot of electrical component manufacturers will produce components like these connector blocks that attach to DIN rails. And there's a connector block. You can see, this can support many amps flowing across it, and you makes all of your wiring very neat. Then you want to do really rapid prototyping. You need a breadboard. So you wire in a common positive there and a common negative, and then all of these vertical rows, they're all wired together. Oops. And then finally, to stop all the components flopping about all over the place, I use what I call posh man's Lego in terms of this totem maker stuff. So here I've got a 12-volt supply, and that's rated to 4 amps. That's why it's so chunky. Mains voltage is coming in here, 2 DIN connector blocks here, passing power into these devices, and then 5 volts and 12 volts coming out here. These connector blocks then distribute the 5 volts and the 12 volts. Hidden under here is the Raspberry Pi, and then I've got the relay hat sat on top. More connector blocks, then a DIN rail to hold all of these components, and some totem maker to mount all the devices on. And there's some guy on eBay I found who makes these 3D printed blocks here that I can mount breadboards on, or the Raspberry Pi. So they're quite useful, because once you get a few components, you need to start stopping everything falling over the place, and these wires can fall out if the thing they're mounted on starts moving around. So another thing that's really useful is this Pwm controller. So if you need to control more than the 2 PWMs that you've got natively on the board, this control up to 16. And then with these jumpers, you can then stack these blocks 6 high, multiples high. So you can get 16 times 16, for instance, servos running off the device. So it's fairly easy to wire up. 5-volt supply, and then a common ground in there, and then the 2 I2C wires coming in here. Excuse me. And then this is an extender port, so you can then extend this and wire on further I2C devices and chain them on. You need extra power because these can be quite power hungry, and you don't want to drive it through here because the amount of current a Pi can deliver is really quite limited. And I've demonstrated that already, so it's I won't go through that again. So then you've got in terms of C#, you just define a class called PCA 9685, reset it, and then set the duty cycles. So that's what I was doing with those the servos you saw in a demonstration, just varying the duty cycle. Now this is where C# is not so great compared to, for instance, Python or C, but then depends what driver's been written. So let's say you go onto a shopping website like shop.pymaroni.com, and you see all these wonderful peripherals, and you go, oh, that's 3-color LED display, that'd be wonderful, and all the 3-colored ink. And then you get it home, and then you see that it's only got a Python driver or a C driver for it, or sometimes a C# driver for it. So generally, if it's a Python driver, it's been written to run on a Raspberry Pi, and if it's got a C driver, it's been written to run on an Arduino or something like that. And occasionally you get a C# driver. So what you see in the shop is not what you can run. So before you go running it, you go googly-eyed and get everything. What you really need to be doing is spending some time with system.device.io. So as I said at the beginning, this is the main namespace you can go on, and these are all the devices that you can use. So it's not a particularly useful list until you get down to the categories here. And you see, right, so these are the analog to digital converters I can use, the accelerometers I can use. Someone's written a driver for gas sensors, liquid sensors, light sensors, barometers, thermometers, and all this. So these are the things that you can do natively with the drivers out the box. So I've showed you that. So, and if you've got no driver, then translate the I2C interface. So this is what I did. So I took the Python driver and went to one of the online convert Python to C# websites you get out there. And then you get this code out of it. And there's a lot of bit shifting operations, which just all seem to work, which is really nice. So sometimes you can do it without having a driver at all. So you've seen the relay hat in operation. So relay hat can drive really high ampage devices. So, so you can run 10 amps through one of these. So you can light fireworks, run high ampage lamps, like you've seen one of my kitchen lights lit there, and also run solenoids. And you've seen the code that I converted in the project.
John, you should have done this with fireworks.
Well, I could have done, yes. But then where would the smoke go in my office?
You could have set a camera for looking out the window and had the firework firing out your window.
It is the most commonly asked question, actually. How do we do fireworks? So what you do is you get a thin piece of wire, and then you run like 2 amps through it. The wire will then burn, will become very hot, and you wrap it around a match head and then attach the firework to that, and then it will set the firework off. And that's how you do it.
Next Guy Fawkes, we're doing a special show. and you're going to set off an amazing display of fireworks.
Well, my partner's already told me that she wants a fully automated firework display next year.
Yeah, right. Hey, maybe we'll invite everybody to your house for the show.
Well, at least they can view the camera feed. Yeah. So once you've got a driver, either one you've written yourself or one that comes with some of the libraries, it's fairly easy to use. You just create a new instance of it, set the I2C register it's on, and then call set relay, the number of the relay, and then whether it's on or off, and then reading back out is the reverse. So you've seen the code for that. Okay, so now I'm going to introduce Blazor. So Blazor is a technology that's used for running websites, and it's a single page application framework. So what that means is when you see a website, it doesn't, and you do have some interaction with the website, or the website changes on the server, those changes then reflected in the browser straight away. This is all run server side, and there's push updates via a technology called SignalR, which uses WebSockets. So when you open the website, it creates a persistent connection with the server. So this is what mine looks like. So for instance, you push a button. So normally in a normal website, it's stateless, and you do a post back of a form. But with the SignalR version, you just define a on-click handler with a C# method called send message. So on the website, when you press execute, it then executes this code on the server without having to do a post back. There you go. And then you've got my method send message on server. So let's say I've got a div or a label on the page that contains some text. Now this is defined using variables on the server. So if I was to change on the some information on the server, the delta in the HTML is what's changed in the HTML will then get pushed down to whatever devices that are looking at that web page. In this case, my mobile phone. For instance here, so I would say the message is an exception's occurred, and that will get reflected on the web page for two whoever's looking at that. So the SignalR pushes messages up to the server and also receives information back. Now we want we're sending messages to an Azure IoT Hub. So I'd like to create a connection from the Blazor site to the IoT Hub. So I use the service connection string here. Now this is different to the device connection string I used on the device. They have different permissions. Don't try and reuse them both across two devices. That will save you a couple of hours of your life. And then you define a method. Let's say my method here. And I serialize that JSON blob that you saw before, and then invoke the device method. So in the Blazor website, I create a connection to the IoT Hub that's persistent, and then I invoke a method in the IoT Hub. You're not going to show me the cap. There you go. All right. Okay. So let's say I want to execute. So what happens when I press the button? SignalR, some JavaScript in the page. It sends a message via SignalR and WebSockets to the server. The server's sitting in Cardiff. The Azure IoT Hub has a persistent connection to my Raspberry Pi. The Raspberry Pi says, I've received a message. This message says, I'm going to turn the solenoid on. Okay, so we can see we can control devices remotely, and we can also see there you go, there's my LED flashing on and off. But that's not really the reason why I've used Blazor here. Is because I don't want to go to the hassle of pushing updates down to whatever devices I'm looking at, say my mobile phone, or in this case, my Firefox browser. So I'm going to press this button here. And then this is going to change here. Now, if you can hear that, so what's happening here is there is some code cycling on the Raspberry Pi, and it's saying, has the state of the button changed? Has the state of the button changed? And it does that every quarter second. When it does, it then sends a message to the Azure IoT Hub. My Blazor code has a persistent connection to the IoT Hub and is listening for messages on that. It then says, oh, something's changed. I've received a message. This is what the payload looks like. I'm now going to do a push update, and it sends down the wire to that bit of HTML. So this device is sitting next to me. This website is sitting in Cardiff. You've seen how fast that is, even with a forced quarter-of-a-second delay. You've got almost real-time connectivity between sending updates down to the device and telling it to do something, and also receiving information back. I'm just going to see if I've got any questions.
No questions.
No questions, good. So you've also got a camera. The camera attaches via this ribbon here. And you've got 3 types of camera: normal, high def, and see in the dark. And they're quite useful. I do another presentation on.
We have a question.
Oh, a question. No, I haven't. What I do know about occasionally connected devices is that if the message can't get delivered, then it's just held in the cloud or on the device. And that's at either end until such time connectivity can be made. So I've sent devices that messages that haven't been automatically sent anywhere, but they're sat. So when the devices come online again, it's processed a backlog of messages in the order in which they were sent. And I assume it handles reliability and poor bandwidth and that kind of thing. I could be wrong. I'm not the person to ask on that. I hope that answers your question. Okay. Yes, so wiring up the camera is just a case of putting the ribbon in the right way around. Yeah, so digital inputs. So you say you've got this rate limiting resistor there. That's what you saw on my device. The reason is you get, if you put a switch without the resistor in, it causes a short between these, and then it fries your Pi. So you need to make sure you got your resistors right. Again, buy a pack of components that have got all of that on for you. Makes it a lot simpler. And then setting up an input is the same as an output. You set up a GPIO controller, define the input pin, in this case 22, as an input, and then you read it, read the value out of that. So I've got a loop in my code that just cycles through and says, has it changed? And then sends that back to the IoT Hub. This is the code that sends it to the IoT Hub. So having defined a device client, I've already provided the code for that. You then said, well, I've got a device event. So this is my own class here with my own payload, and then serialize it to JSON, convert it to bytes, and then it pipes up to the IoT Hub. IoT Hub is backed by Event Hub. which I think is Kafka as a service. So if you would go to any of the presentations on Kafka anywhere on message passing or event-driven architectures, then it will have Kafka mentioned somewhere along the lines. It's the granddaddy of message passing. So LinkedIn, Microsoft, Oracle, they all use it. It's very, very powerful. It supports a number of different protocols. So messages can be routed in a number of different ways to blob storage or service bus. In this case, we're just setting the event hub to route messages to Blazor. You need to make sure that the fallback route is enabled, otherwise in the IoT hub, otherwise the messages don't pass anywhere. And then you receive messages from the event hub on the other end. So this is my Blazor code. So I just defined this class called IoT Hub Service, pass in my configuration parameters, and you set up blob storage connection string. So why do you need blob storage? So Kafka, you'd never delete messages. That all you do is just move the pointer on. So you need to keep a track of where it read up to last, and the means by it does that. It keeps a record in blob storage. And you can define a container name where it can keep all those bookkeeping messages. So create if it doesn't exist, and then create an event hub consumer. You can define different consumer groups if you've got a great volume of messages passing through, and then define an event processor. That's for your bookmarking, that's your consumer group, and then you pass the event hub connection string, which you get from the Azure portal, and the event hub name. Then you pass in two event handlers. So you say, when an event happens, I want this code to handle it. When an error happens, I want this code to handle it. And you say start processing. So when that hits, any messages that have been queued up will start being passed sequentially into these two handlers. This is my event handler. So you just it passes in process event args. You just get the body out of an array, deserialize it. So that's my own custom class of the device event. So I know that it's got an event date, a message, and the method that has been activated on the device. And then in Blazor, I call this on event received. So the Blazor front end subscribes to that, and so when it gets called, it can then update the HTML in the front end, and I don't have to bother with any updates or WebSockets or that like. And then finally, you have to update the checkpoint in blob storage, so it only receives the message once and once only. And I've done that demo already. So yeah, every so often it pushes this device update message to Blazor and says, yeah, I'm alive. When it turns on, it sends a message that says, hi, I'm available. And as you've seen, when I change the state on the device, it also updates it too. So it's quite powerful. So in summary, you have the power of using C# to control lots of different types of hardware, whether it's ones and zeros based, pulse width modulation into integrated circuit or camera. With C#, not everything you can buy can be controlled yet, but that's just as true as if you're developing exclusively in Python or within C. There aren't drivers for everything, but as long as you can convert the I2C code into something that you're happy coding with, you can go anywhere with it. We've demonstrated that the Azure IoT Hub can be used to connect you and control your device. So we saw with the website, we were sending packets down to the Raspberry Pi messages. The Raspberry Pi was interpreting that and then turning things on and off based on that control message. And then also it was sending messages back to the IoT Hub, which the Blazor site was then listening to, and then it would update the Blazor site with the telemetry from that. And it worked pretty much live. So there was very little delay between me pressing a button or receiving some telemetry and it updating. So there's a couple of get started resources apologies if this is a bit basic. I'd really recommend the Pi Hut starter kit. That's everything you need to get going on a Raspberry Pi. There are many how-to books on Raspberry Pi. I would recommend the official one. It's really well written and very straightforward and very concise. And if you want to make the electronics easy for yourself, the 45-in-1 sensor pack is a really good place to start, and buy some jumper cables. So there is demo code on my GitHub site. I'll be stressing that this is not enterprise level code. This is demoware. So don't anyone come back to me and say there's no unit tests with this. I know it was written very quickly. All the slides are on SlideShare, and feel free to connect either on Twitter or LinkedIn. As I said, I'll be putting those links in the meetup site, and the slides are on SlideShare.
Awesome. Thanks, John. Okay, so it's question time. Let me put my little banner on. Where's question time on? Time for questions. Okay, we've got a couple ones. In fact, actually, we've got some feedback from Charlie following his question about using mobile data connection. So I asked the question. Interesting question. Do you have any advice on how it can work? Not directly from a Pi, Azure IoT Hub, but have used separate 4G router. Was keen to see if there was a Pi add-on.
Pi.
So, John, you could stick a 4G dongle in to get the connectivity onto the Raspberry Pi, and then connect to IoT Hub with Azure and do it that way, couldn't you?
Yeah, you need to connect to either the Wi-Fi or the physical Ethernet port, I would imagine.
Charlie, also message size quantity becomes important for mobile connection, not so important for Wi-Fi. So it's also coming from that cost concern as well. Fair point as well. It's one thing you do need to consider is how much data is going to be flying around, because if you're using stuff like mobile connectivity, you can ramp up bills. Investment Viking girl. Is there anybody in Copenhagen? I don't know. Is there anybody in Copenhagen?
I hear people live there.
Yeah, I've heard the rumor too. If you go onto our meetup page, which we have 7 now, with the affiliation of Scotland now as well. If you put in there comments and stuff, anybody we do have people across the whole of Europe. So I'm sure there is somebody there. I want to make some friends who have common interest here, don't we all? Thanks for calling.
There is a Danish IoT conference I was aware of, actually. So, yeah, there are IoT people in Denmark.
There's quite a community in Copenhagen. And there's the Things Network have definitely got a big presence there as well. And if I am doing an industrial IoT project, do you recommend Raspberry Pi?
Well, this is where me and Paul fight.
I say no.
I say yes.
I say if you're doing something on your desk that you might think about doing there, start there, but don't put it in an environment in a Raspberry Pi, because I
know people who have Raspberry Pis in production, and they're quite happy with them. So there you go. There's the flip side to that argument.
It depends on the environment. Saying that, I'm no longer affiliated with the company that I was affiliated. So as long as you put it in a nice casing, which makes sure that can help you with the vibration and the dust, then you'll be all right. But if it's critical data stuff, you might want to invest in something a little bit more robust and industrial grade. How about that, John?
It's a fair argument, Paul.
Actually, I haven't looked at the casings for Raspberry Pi for about a year now, because there was supposed to be some stuff coming out.
So you got that one. That's a DIN rail mount. You got a DIN rail on the back, and then you've got a sleek and sexy.
That's the one I've got.
Yeah, I mean, there's so many different form factors.
Yeah.
Just have a look on shop.pimeroni.com. There's a few dozen.
What's that? Because of the cost. Yeah, it's all about the cost. Bruno, Dave, any objective comments about using AWS versus Azure?
Yes, you can probably do exactly the same on AWS, but I can't do that presentation.
There you go.
If anyone would like to do that presentation, please get in contact.
Yeah, for sure. We haven't had AWS on for a little while, actually.
No, we haven't. No. They petered off, didn't they?
I'll have to get in touch with them and reignite that one as well. Any other questions before we go for a beer? Just while we're waiting to see if there's any more comments or questions. As I mentioned earlier, we have the solution marketplace. If you've got any use cases of your solutions that you're making that you want help to get to market in front of buyers, go to our iotnorth.uk website, and that's iotnorth.uk, not .co.uk, although I do own that domain. I just haven't connected them. And you can find the solutions page on there. It's free to register. We'll add it to the social calendar, and we'll promote your solution for you regularly. And we also have the forum as well. If you want to network like Investment Viking Girl and connect with each other, go to forum.iotnorth.uk and you can connect and chat with each other. Just be polite and nice. Otherwise, we will remove you. Not that we've ever had that case so far. If you want to speak on one of the shows, like John's just done a great thing, we're very keen to have technical demos and stuff. But if you'd like to do a bit more high-level side of things as well, or if you'd like to be part of a roundtable, get in touch, info@iotnorth.uk email address, or through LinkedIn, and we'll love to hear from you. On that note, John,
we'll say on AWS versus Azure, they're both investing an awful lot of money in this. Like we if you go through our YouTube channel, we had an AWS presentation early in the year where they did a fantastic demo on digital twins. Azure have a very similar offering where you can surface data about a whole ecosystem of devices in a graphical interface, and it's very, very impressive.
Interestingly, Google dropped off a little bit with the IoT space, didn't they? A couple of years ago, they were really pumping into it, and
I think they're still catching up on with Azure and AWS for everything else. I think they've got to focus somewhere.
Yeah. We've got some conversation going on now. So, how to make Raspberry Pi more secure?
Don't know.
Question on sport, please. Although anybody who's on live who wants to answer these questions, we'll pop them up live to you as well. Oliver Hamilton. I don't know this gentleman at all. Not that I haven't just been on several calls with him today, my good colleague from Intel. There's your answer there in regards to processing power need for industrial IoT projects. And a nice little bit of advice on devices as well.
A lot lower power. Happily, you can do C# on that as well. So that's my happy space.
If you get commission from the Raspberry shop, Coleman Clark's off to buy one. Excellent intro. Many thanks. Thanks, Coleman. And Mr. Wallace, beyond brilliant. John and Paul, you're more than welcome. Thanks very much for joining us again. And Jay, fantastic stuff. Thanks, guys. You're more than welcome. Hey, we're here again. Hopefully for a roundtable for December. We will take a break in January, as we usually do, because we're a bit hungover. And then we'll be back in full effect from February. We've got a couple of things lined up at the moment for those shows. If you would like to be part of those, please do get in touch. And we'd love to have you part of it. Well, IoT North, it's a community. It's not just us sat here talking with each other. It's about everybody contributing and supporting each other as well, and accelerating that learning curves. In February time, hopefully I'll be able to share some of the stuff that Mr. Hamilton and I have been doing and share with that, which is pretty cool. And I might pull John in to do the beyond the module that we do with some of the stuff that you've just done there, John. I'll chat with you later about that. Excellent. And on that note, I'm going to stop waffling. I'm going to go and get some dinner. John's going to go for a beer. And I'm going to find the outro. Thanks very much and good night.